Now the obvious way to apply what we've just learned about spring forces is to make a pop gun. Okay, so suppose I have a tube with a spring in it. Okay. And I take a mass, M, and I put it in the tube, and then I compress the mass back in the tube so that the spring is compressed, and there's a little lever to hold the spring in place. And so this is a pop gun. I flip the lever, the mass is sent, the spring expands, the mass is sent off at some velocity, V final, out the end of the pop gun. So you load the pop gun, you compress the spring, you hold it down with a little lever, you pull the trigger, the spring uncoils, and it pushes the mass out at some velocity V. Okay, so let's put this in terms of energy. We start off, we have an energy equal to 0. The total energy is equal to 0. The spring is not compressed. We haven't done any work. We do an amount of work, external work, equal to 1/2 kd squared to compress it. That's what we just calculated. And then we let go, and now the spring is doing work. It's exerting a force going from here to here, and that amount of work is going to be equal to 1/2 k times the distance that it expands, and we get the final kinetic energy. So we can almost look at this very quickly and figure out how the work was done. The external work to compress the spring, let's see, we compress at a distance d, is equal to 1/2 kd squared. Okay. Then when the spring uncoils, the work done by the spring is going to be 1/2 kd squared as well. Now we're going this direction. The force of the spring is going in the same direction. And so this is going to be positive work. And that's going to be equal to the final kinetic energy of the mass minus the initial kinetic energy of the mass. That's going to be equal to 1/2 mv final squared minus 1/2 mv initial squared. Let's see, so we started off by with the spring compressed, the mass was not moving, the initial velocity was 0, and so we could calculate what the final velocity of this will be. We would get that Vf squared is equal to kd squared over m. See, I do that right. 1/2 mv squared is equal to 1/2 kd squared. The 1/2s cancel out. We get kd squared over m. So V final is equal to k times d squared over m square rooted. All right, this is a good chance to check your ability to see if an equation makes sense. This says that the velocity of the mass as it comes out of the pop gun is proportional to the spring constant of the spring. Remember, the higher the spring constant, the stiffer it is. Well, that kind of makes sense. The further the spring uncoils, the greater the distance the spring is pushing the mass, the faster it goes. And if I make the mass very large, the velocity is going to decrease. I will get a higher velocity with a small mass rather than a large mass. That makes sense to me. So that is a good way to check your answer whenever you get something like that. So we did work, then the spring did work, and all that got changed into kinetic energy.